This drone interceptor is designed to catch light UAVs. High power-to-weight ratio is a competitive advantage of this concept. It allows the drone to fly fast. At the moment of attack, the rotors accelerate and detach from the frame. At the same time, the net fastening straps are released. The Kevlar net blocks the target's rotors and disrupts the glider control. The interceptor can be reused. The interceptor descends using a parachute and emits a sound signal. Drone rotors are used to spread the net. High-energy rotors allow the use of a larger net. The interceptor does not contain any prohibited components. Racing drone components were used. Several containers with interceptors can be placed on a patrol car. A racing pilot can single-handedly operate the complex. In a navigation mode, the drone is controlled like a multicopter. In an attack mode, the drone is controlled like a plane. Telemetry data is available to the operator in real time. A simulator was used to predict technical performance. Before an attack, the target can be circumflown for identification. The innovation was first bench tested. The subject of the invention is an airframe, motor mounts, net, and parachute fixtures.
Pools opening. These are some of the things we expect with summer.
After 2 years of designing and prototyping, we're ready to introduce the Spry, a waterproof drone that floats like a boat, can briefly submerge underwater, then flip back to fly in the air at over 40 miles per hour. It's a combination of a racing quad and a photography drone with a robust waterproof body. And yes, the first ever waterproof remote control. The waterproof remote control has a built-in monitor that allows you to watch the live video stream and on-screen display information. The Spry can also send its video signal to several monitors simultaneously, so you can share your flying experience with your friends on the spot. The Spry's 4K camera tilts up and down to always point in the right direction during flight or while floating. This allows you to see what's underwater. Another cool feature is the expansion port that allows future accessories to be attached on the bottom and enhance the Spry's capabilities. You can turn the GPS on and off from the remote control to fly freestyle, or activate its advanced flight features like Follow Me, Object Orbit, and Return to Remote Control Location, so that if you're on a moving boat, the Spry will always come to where you are. If you're more into robotic flying, you can use the Spry's app to set up waypoints on the map and fly a designated path completely hands-free. The Spry is compact and comes with everything you need to fly the moment you get it. The carrying case, battery, remote, and charger.
We're also doing something that we don't think has ever been done before. We're releasing a series of videos bringing you inside of the factories that make some of the components for the Spry, and also show you the working conditions of these factories, and also learn how LiPo batteries are made, propellers are made, and how the whole manufacturing process works.
We've spent years in the design stage to push the limits and redefine the capabilities of drones in general. The only thing that's missing to make the Spry a reality at an affordable price is you. By supporting this project, you will be the first one to get your hands on the very first Spry. Check out the different reward levels and help the project go viral by sharing it with all your friends.
Engineers at Caltech have built a robot that combines flying and walking to create a new form of locomotion. The robot is called Leonardo, for Legs Onboard Drone, or LEO for short. LEO has a pair of multi-joint legs for bipedal walking, but also has propeller thrusters that make its walking more stable and allow it to hop and jump. The goal of LEO is to give a robot unprecedented walking ability, and also to study and solve problems posed by hybrid locomotion. LEO is capable of many tricks: tightrope walking, stair flying, skateboard riding. LEO is helping engineers rethink how robots could move in the future and could open up difficult environments to robotic exploration.
We present a modified quadcopter design that uses passive hinges to enable a number of behaviors, including flight through narrow tunnels, simple grasping, perching on wires, and passage through small gaps in projectile motion. The main significant difference between the proposed vehicle and a conventional quadcopter is the use of passive hinges that allow each arm of the vehicle to rotate freely between the unfolded and folded configurations. Note that no additional actuators or sensors are required beyond those used by a conventional quadcopter. These additional unactuated degrees of freedom enable the vehicle to hover with two opposing arms folded. This is achieved by reversing the thrust directions of the propellers attached to the two folded arms. Because the vehicle is designed such that the thrust axes of the folded arms are offset from one another, a yaw torque is produced that counteracts the yaw torque produced by the unfolded arms. We utilize this new ability in a number of ways. First, by folding two of the arms, one of the dimensions of the vehicle is significantly reduced, allowing for flight in tight spaces that would be impassable in the unfolded configuration. Here we show the vehicle using this property to fly through a narrow tunnel which the vehicle would be unable to traverse in the unfolded configuration in a near hover state, even with perfect accuracy. Next, we demonstrate the use of the vehicle to perform a simple grasping task, where a box is moved from one location to another. After landing, the two arms are used to firmly pinch the box before taking off, after which the box is moved to a target location by the vehicle. Note that this task requires a specially sized box, and the allowable mass of the box is significantly limited by the maximum vertical thrust the vehicle can produce with two arms folded. Another task enabled by the free rotation of each arm is the ability of the vehicle to perch on hanging wires. When all four arms are folded, the center of mass of the vehicle is shifted below where the wire contacts the vehicle, leading to a stable perching configuration without the need for any specialized mechanism. Finally, we demonstrate the ability of the vehicle to fold all four arms simultaneously in order to traverse narrow gaps in projectile motion. After a short trajectory used to gain upward velocity, each of the four propellers are spun in reverse in order to fold the arms. While the arms are folded, the attitude of the vehicle is controlled by varying the reverse thrust forces produced by each propeller. Finally, the propellers again change rotation direction, thus unfolding the arms. Note that when flying in the unfolded configuration, the vehicle has similar tracking performance and power consumption compared to a conventional quadcopter.
Researchers at Virginia Tech have created a new shape-morphing material. This material starts as a flat sheet, but can morph into complex shapes. It's capable of rapidly changing shape, which instantly fixes the material in place, and reverses using a liquid metal heater. The researchers introduced this mechanism as reversible plasticity, turning a common failure mechanism into a strength. It's made from multiple functional layers, using advanced metal alloys and elastomer. The material is structured with patterned kirigami cuts, allowing the composite to morph into complex shapes that become fixed into load-bearing structures, while also allowing for large and reversible motions. These materials are changing what soft robots can do, and adaptability is being introduced into soft systems. By morphing between multiple, stable, load-bearing shapes, one soft robot can drive, morph, then fly away, allowing machines to evolve when the task requires it. Robotic components like propulsion systems can be integrated, which introduces complex functionalities to soft robotic systems. These machines can deploy from a compact shape to a functional one, allowing them to explore new environments. And return with cargo, before retracting to await its next task.
Fruit farmers' most difficult task is organizing the harvest. We need a large number of reliable pickers, and we have to pay wages, organize visas, housing, food, healthcare, and transportation. Costs are rising all the time. This is hard, seasonal work, and other crops can pay higher wages. Young people all over the world are abandoning agricultural work in favor of higher-paying, full-time urban jobs. After realizing that fruit farmers were going out of business, we began an urgent search for a technological solution to solve these problems. That's when we found Tevel. They offered us a 21st century way to pick fruit. Using Tevel's harvesting management application, we tell the control center how many robotic pickers we need, when we need them, and for how long. When we need them, Tevel's control center sends the technicians with a fleet of pickers. After a short setup, the robots select, pick, and box only ripe fruit ready for market. With the robots working day and night, the application provides real-time updates on harvesting progress, time to completion, quantity picked, and costs. This is our future. Tevel, bringing prosperity to fruit farmers for generations to come.